Hello there. Now, this section is about indices, and I'm going to talk about the basic rules of indices and show you them. Now, you might be wondering, what's an indices? Well, if we have, let's say, 3 to the power of 2, this number here, the 3, is called the base number. And this number here in the top right-hand corner can be called the index. It's also known as the power, and it is also known as the exponent. So, 3 names for the same thing. Now, these are the definitions. This is what names you give them. Now, what does it actually mean? What does it equal? Now, 3 to the power of 2 means that we have got 2 lots of 3 multiplied together. Okay, so we've got 2 3s here, so we've got our first 3 and our second 3, and we multiply them together. So, to continue that theme, we've got 3 to the power of 3, and that will be 3 3s with multiplication signs in between them. So, you can see how to generate that pattern from there. So, 3 times 3, once again, going back to 3 squared, equals 9. And 3 times 3 times 3 equals 27. Now, I can make this a bit more general by not talking about actual base numbers that have particular values. Instead, I can talk about variables. So, I can say, for instance, that y to the 4 equals first y, second y, third y, fourth y, all multiplied together. Now, there are 3 basic rules of indices, and I'm going to talk about each of them one at a time. So, first rule. Let's say I had a to the m. Now, a to the m would equal ma's multiplied together. So I'd have a times yada 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 times a. And I've got my first a, my second a, and my nth a. So I've got ma's all together. Now, if I talk about a to the n this time, it's the same sort of thing again. I've got a times a times a times a times a times a. And I have got NA's all together. So I've got first a, second a, all the way up to my nth a. Now, if I decided to multiply a to the m by a to the n, I would have m lots of a times a, once again. Okay, so I'll have m lots of that, and I'm multiplying it by n lots of a once again. So, on the right-hand side of this equation, I'll have written out m lots of a's and put multiplication signs in between them. I would have written out n lots of a's and put multiplication signs in between them. So, altogether, I will have m plus n as a power. So, that's the first rule of indices. And as an example, I can show you, for instance, that 3 to the power of 4 is obviously and 3 to the power of 5 is now. If I multiply them together, I would have 9 3's altogether with multiplication signs in between them. You can see why powers are so handy. You don't have to actually write this all out. So, we've got 9 3's with multiplication signs in between them. So, the next rule to think about is if we're dividing things. So, let's say I had 3 to the power of 8 divided by 3 to the power of 6. So, that'll be 3 times 3 times 3 times 3 times 3 times 3, 8 times altogether. And in my denominator, I would have 6 3's multiplied together. Now, we can cancel this down, we can simplify this, because every time there's a 3 on top and a 3 underneath, we can cancel out that pair. So, they cancel because 3 divided by 3 equals 1. So we can cancel out that pair, we can cancel out that pair. We don't have to actually go through it by hand and cancel out everything. We can just think about it. We've got 8 3's on the top, 6 3's on the bottom. We will have 3 times 3 left over on the top after these 6 pairs get cancelled out. So we'll end up with just 3 times 3 surviving from the numerator, and that equals 3 squared. So 3 to the power of 8 divided by 3 to the power of 6 equals 3 squared. Now, as a general rule, this means that a to the power of m divided by a to the power of n equals a to the power of m, the number of a's in the numerator, take away n, the number of a's in the denominator. Now, that's a single power. That will be a single number. Okay? So, just before, 8 take away 6 equals 2. Now, remember, this side here could also be written as a to the power of m divided by a to the n, but it means exactly the same thing. Now, the final basic rule to talk about is powers within powers. What do I mean? Well, For example, if I had a to the power of m, we know that's going to be a times a times a times a times a times a m times. Now, if we had a to the power of m in brackets and all to the power of n, that is equal to a to the power of m times 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 a to the power of n times. So every bit that we have here, every bit like this, has got m lots of a's inside it. You write out a m times for every time you see a to the power of m. And if you've got n lots of m lots of a's, that means that a to the power of m to the power of n equals a to the power of m multiplied by n. Now, remember, you don't have to write the multiplication sign in. You can just put the variables right next to each other, and everyone will interpret that as being a multiplication. So, I'll give you one example of that. If we had 3 to the power of 2 to the power of 5, that is equal to 3 to the power of 2 times 5. And so, of course, that'll be equal to 3 to the power of 10. Now, you can test this out on your calculator if you want to prove it to yourself, or work it out by hand, of course. So, remember, 3 to the power of 2 will be exactly the same as 9. It equals 9. So, you should be able to prove that 9 to the power of 5 equals 3 to the power of 10. Hopefully, that will satisfy you.